Okay, so hopefully, now that we've like traced recursion and we had to like, do that a little bit tediously, I hope it wasn't very like hard to follow. We can kind of speed through and look at recursion from a higher level when we implement the search function. In the assignment that deals with binary search trees, like the two thing, like you need to do like a search function. We're gonna do that now. It's very simple. The delete function is the difficult one, and that's why I'm leaving it as an exercise. Because truly, like, you have to think about it and you have to try it by yourself. I don't think you need it in the assignment, but it's important, like, to really do a binary search tree. It's nice to have the insert, delete, and find. Okay. Some tips with recursion, I feel like tracing it helps, but when you come to code it, truly you'll find that there's really like, it's not, recursion for me is one of the most challenging aspects also. But when like the best thing that works for me is if when I come to code recursion, I shouldn't, like, don't think about it too much, just like code at a very high level and consider only one case at a time, and usually it's gonna work. We'll try to implement this strategy now, hopefully. Okay, خلينا, let's go back to here again. احنا قلنا when I'm searching for something. Okay, let's say I'm searching for مثلا element number 24. Okay, لا خلينا, let's do a deeper one. Let's do, say I'm searching for 5. Okay, always start at the root. Okay, start at the root. I ask, is 5 less, no, this is greater. Okay, is 5 less than 15? It is. So I'm looking here. This is my new problem, my new sub-tree that I'm looking in. Halas, I forgot about everyone out here. Okay? Who was I looking for? 5, yeah. Okay, so now 9 is my root. Start at the root. Is 5 less than 9? It is. So I look at this subtree. Now, what have I done here? I'm saying بقى, is 5, this is my new root, but it is the data, so I found it. Immediately, I'm just gonna draft that somewhere here. برضو كالعادة, we're gonna do a private function and a public function. فإن my private function, immediately عرفت, I discovered something here. I'm gonna just draft something really quickly. Bool, عشان I know it's a boolean function. Find. وكالعادة, يعني I'm just drafting, but I know it's gonna need like the root. صح? And what type is the root? Node t pointer root, and then it's gonna take the data. What did I discover here? What did I discover? If my root data is the data is the data I'm looking for, then return true, I found it. Okay, I discovered this. That's interesting. So I just, when I was doing this over here, I discovered if I'm the root, then I found it. If my root is null, let's search for a value that doesn't exist. Okay, let's search for a value that doesn't exist. No, I want to erase this. I want this to go back to being neat, tidy. Okay, that's the best I can do. Let's say I want to search for 1. 1 doesn't exist in my tree, so if I started the root, is 1 less than 15? It is, so I'm looking at this subtree here. So I started the root. 9 is now my root. اللي هو a root, which is this thing basically. Okay. Is 1 less than 9? It is. So I'm looking at this subtree. Okay. Is 1 less than 5? It is. So I'm looking at this subtree. 2 is my root. Is 1 less than 2? It is. So I'm looking at this subtree. Who is the root? It's null. If I reach something that's null, that means I couldn't find it. صح؟ فغالبا I want to say if a root equals null, then I couldn't find it. Return false. Okay, I'm gonna remove the braces because they're not necessary. صح? Okay, what about the process that like this circling process, the process of saying يعني where I say the left to right subtree, صح? What do I do? How did I do that? Like where's the recursion happening here? صح? يعني I just want to say without noticing, what we did here is one of the most important steps of recursion. We did the base case. Okay? That's one of the most important steps of recursion. We did it without noticing. I think it's better to think about recursion like this. We'll keep going. Okay. فإف I found if I found it خلاص return true. We don't really need an else here. هنا between them we don't really need an else. عشان if it's null خلاص you couldn't find it, go back. Like there's no else. Like there's no need to continue on the function if I couldn't find it. You know what I mean? Similarly برضو if I couldn't find it. Like if I found it برضو return true خلاص, like I don't really, you know what I mean, need to do that. بس if بقى عايزين we want to do the recursion. Again, let's take a nice example here. Let's say I'm searching for 2 مثلا, just so that we can have like, okay, I think. But what do? I start at the root. Is 2 يعني لا خلينا else هنا, let's do an else. Okay, if is 2 my root? يعني did I find it? Is it this one? No, it's not. Then what? Is it less than my root? If it is, then I search here, I'm recursing here. For else, if is my data less than the root data? If so, then I want to look in my left tree. If I'm recursing there. يعني recursing and I'm calling myself. Find with who بقى the left subtree. A root at left. صح? And then take my data, the thing I'm looking for. Else طبعا I have to be يعني greater. ما قداميش حل تاني, because if I was equal I would have returned true, right? else find a root at right and data. غالبا كده, and then I'm gonna do an underscore عشان this is private. And here out here in the public I'm gonna do void find t data, or no bool عشان this time like there's a meaningful return type. Return the private function and give it the root عشان the first time خالص we started the actual root, which is a private attribute, and my data. Let's test this function. Okay, let's run it first to make sure as always there's no errors. Wow, I'm so impressed I actually did something and it didn't return errors. من أول مرة. Okay, I don't know why it's not like stopping. Okay, good. I don't know. Okay, so let's find ماشي. Okay, at this point my binary search tree is empty. At this line, at line 85, it's empty. So المفروض if I go my binary search tree dot find anything, it should give me false. But like find like anything, it should be false. Should get 0. Why? Oh, silly me. I'm not calling the private function. Why is that? Silly me. You need to return the error. You really need to return something. If I return the find, so basically we're saying, like we said, if it's like if we're at the null case, like we said, then we haven't found it. Return false. If it is the current node I'm looking at, which is a root, then return true, we found it. Else, find it, return the answer of searching, of redoing this problem, considering the left subtree and then considering the right subtree. But that worked. Let's go back down to our main function. احنا we're finding 10. Oh, we need to see out it. But this should give me false. I should see 0. عشان 10 doesn't exist. It went into the base case, it didn't find it. So let's see, but I want to insert 15. Let's see if I could find it. See out my binary search tree dot find 15. That should be true. عشان خلاص like 15 is inserted. Good. It gave me 1. Let's search 10 برضو to make sure. عشان now that the tree is full. Still couldn't find it. Good. Let's move this after the tree has been constructed and search for the theme. Has been found, and yeah. So our recursive find function has worked, and you see how, like, when we looked at it from a higher level, like, perspective, very logically, like the way we think about it naturally, we managed to be able to do it. Like, oftentimes when you're doing recursion, you can get very caught up in the details, and then you can get overwhelmed. But if you look at things Bardo from such a very high level, like if you understand the problem very conceptually, usually you will be able to implement recursion. So as an exercise, try to implement the delete function, and then trace the find function like we traced this insert function, remember? So yeah, that's it.